This how-to video is acid bases and buffers worksheet 1 question 1n, and I've pasted the details onto the page in front of us. I've also included some additional information which we're going to need to answer this question. So to begin with, what we need to do is we need to establish just how many moles of sodium hydroxide we've actually got. And we do that like this. So we have 0.005 moles, but this number of moles is not in 1 decimeter cubed. We need to look at the question now, and if we recall, solution M, we had 400 centimeters cubed, and what we've just done is we've just put 5 centimeters cubed of the sodium hydroxide into it. So the actual number of centimeters cubed of solution is 405. So what we now need to do is to work out the concentration in moles per decimeter cubed of the sodium hydroxide in that 405 centimeters cubed. And we do that like this. So what we actually have then is 0.0123 mole per decimeter cubed of sodium hydroxide. Now, before we progress with this question, what we need to do is think about what's happening chemically. And we've done this before. What we've got is a neutralization reaction between the sodium hydroxide and solution M, which, if we recall, is benzoic acid. So what's basically going to happen is, if we've got this concentration of acid, this concentration of sodium hydroxide is going to neutralize this acid, and it's going to neutralize 0.0123 moles per decimeter cubed of it, like this. So, put simply, when we put the 5 centimeters cubed of the sodium hydroxide into the 400 centimeters cubed of benzoic acid, what we've effectively done is we've changed the concentration of the benzoic acid down to 0.0197 mole per decimeter cubed, because we have neutralized a chunk of it. So the next stage of this equation is to work out, well, how has that had an effect on the hydrogen ion concentration? And to do that, we use our acid dissociation equation like this. So here's the equation, and what I've done here is I've rearranged this equation to make hydrogen ion concentration the subject of the expression. And now all we have to do is to put in the values that we know. We know Ka, that's given to us. We know Ha now, which we've just determined. That's the acid concentration after it has been neutralized, or part of it has been neutralized by the sodium hydroxide concentration. And we know the A- concentration because this is a strong alkali. What we're saying is that the A- element is equivalent to 0.0123 mole per decimeter cubed, because all of this dissociates. So effectively we've got 3 known values which will enable us to calculate the hydrogen ion concentration. So let's just do that. So here's the final answer then. I've substituted in the values that we know, some of which we have determined in this experiment, and I've arrived at an answer of hydrogen ion concentration which is 0.0001 mole per decimeter cubed. And then pH is simple. All we need to do is to take a negative log of this value, and if we do that, we get a pH of 4. So in summary, the pH of solution M after adding 5 centimeters and 1 mole per decimeter cubed sodium hydroxide to it is pH 4. Now in this question there are certain bits which can be shortened or joined together. I could effectively join these two sections together by simply dividing this part of the equation by 405 instead of the 1000, and that would give me this value. However, chosen to do it this way because it represents all of the stages in the thinking process to arrive at the final answer. Hope this helps. Thanks.